All right, we would like to welcome all of you again to day two of Nurse New User Training and Best Practices on Perlmutter. Hope everyone had a wonderful holiday off yesterday for Juneteenth. Again, I am Charles Lively, a Science Engagement Engineer and Consultant here at Nurse and the User Engagement Group. And I am also joined by several other of our nurse staff, so I'll allow for them to introduce themselves again. Libby, you want to kick it off?
Yeah, so my name is Lippy. I am also a science engagement engineer at NERSC. I work remotely, so I actually live up in Oregon. I have been at NERSC for I think I'm coming up on like 4 years soon, I think. No, yeah, 4 years. Um, and before this, I finished my PhD in physics, so I defended my dissertation in 2021 remotely, which was a very interesting experience. I was a very novice HPC user, and I felt like the whole time I was using NERSC systems during my PhD, I kind of always felt like I wasn't sure what I was doing. So most of my job now is working on training and new user experience and just trying to improve that for everybody. So um, hopefully, this training will be useful for you. And as always, Charles and I are always looking for good feedback to help us improve this experience for others. So thanks for being here.
Helen, did you want to do a quick introduction of yourself too?
Sure. Yeah, my name is Helen He. I work in the same group, user engagement group as Charles and Libby, and also as in Lisa online as well. Being with Nurse for very long, being long time HPC consultant, and being like user side, research user group side of POC for lots of nurse systems, flagship system, the last 15 years or so. And recently I work a lot on training. So welcome to the new user training. Welcome to NERSC. And you'll be having a lot of more chances, opportunities to get more advanced training down the road. So hopefully you'll do a lot of good science on Barometer and in a few years on Doudna.
Awesome. Lisa, did you want to introduce yourself again?
She might not. She said that she is going to be monitoring the Q&A, and she has a
Okay.
lot of background noise because she's watching her daughter right now. So
Okay, no worries. All
yeah.
right. Justin, did you want to do an introduction? And well, first, let me do an overview of everything for today, and then Justin, you can take over since you're first up. And so everyone, today we'll be going over a few things related to Perlmutter and the programming environment. So Justin is going to kick things off with an overview of our exhaustive programming environment available on Perlmutter. Then I'll talk about running jobs and some best practices, and Lippy is going to finish up with giving you a primer on Jupyter as well. That will wrap up, and then we'll have a few interactive things as well as introducing you to our Canvas course on new user training, an overview of that. But we will allow for Justin to introduce himself and kick things off.
Okie dokie. Let me start. Oops. Let me share the slides. All right, are we in a slideshow?
Yep.
Okay. My name is Justin Cook. I'm a software integration engineer at NERSC. I work in the programming environments and models group, which means that all of the tools and libraries that you use to build and run your software are partially my responsibility. We do share that with Cray since it's a Cray system. I'm one of the few non-PhDs at NERSC, which is great because it means I learn a lot of things from everybody else. And before this, I worked at Cray for 10 plus years in industry, And after that, I worked for Lenaro, working on the Linux kernel testing. And then after that, I worked at Scilabs, working on Singularity or Aptainer, whatever you'd like to call it. So there's four kind of main ways for using software on Perlmutter that I'm going to talk about. And this is kind of, like I said, for the newer people. You log into Perlmutter and then now what? How do I get my software? How do I do my science? What do I got to do? So we have something called environment modules that you can use that can modify your environment and access software. You can use containers or containerization. We have several different runtimes that you can use to pull those in. You can compile your code from source. That's something that a lot of developers have to do. And for a lot of other custom type libraries or custom applications, you might have to do that. Or there are several different package managers or software stacks built on top of these package managers. You have examples of Conda and SPAC as package managers, and then E4S, which is the exascale software stack. That's a stack built on top of SPAC itself. So first thing we're going to talk about is modules. So modules are pre-installed software that we already have on our system. The default Python is really only meant to service the system login node itself. That's why it's installed as part of the system packages. But we offer several other Pythons that are newer and have specialized modules or Python modules already added to them. Things like MPI for Pi, Matplotlib, all sorts of different things added. All you got to do is load the module, you do a Python version, and then if you want to see what's installed, you can use pip or you can use other different tools to see all the other different Python packages that we install with our Python. Now there are a set of default modules that are loaded whenever you log into the system. They show what version of the programming environment you're using, what compiler you're using, the hardware targets that you're going to be using, and the version of CUDA toolkit by default. And that's because by default, Perlmutter is accessible using both a GPU and a CPU for doing computation. You can swap out the GPU module and switch to a CPU only standard, which will take out CUDA and all the other stuff. But these are the ones that you kind of care about here. And again, these are a little out of date because as we move forward, these versions move forward. So with LMOD, if you are looking to get a list of modules that you have loaded, you'll use module list. If you need to load or unload a module that a piece of software that you have, use load and unload. Obviously, you can use module help to figure out what's in that package or that software stack that you want to see. Module show of a package is very interesting. It shows you what variables we set in the background to make sure you have access to that. And then there's module avail, which will show you all the things that are open by default. And then module spider, which allows you to search through all modules installed on the system. And all that means is that sometimes some of the modules are hidden by default, and that's just because some of the modules require other modules as dependencies, and module spider allows you to search through all of the modules at once. And you can get more information either on our docs or on the LMOD website. So module avail, while it does show all of the modules that you have loaded and available by default, it's not ideal 100% to search because again, like I said, some modules are hidden, like some versions of HDF5 or NetCDF are hidden when you don't have certain other modules loaded. And so module spider will make sure that you find all of those. So when I said about loading modules or you're loading a piece of software, what does that mean? Well, these are some of the things that we're doing in the background when you actually run module load. And these are all commands that are in Lua. Lua's It's a very small language used for a lot of different things. It's very much a kind of a meta programming language, right? And so, like for example, for HDF5, you have conflicts with other HDF5s that you don't want to be running. You have some basic information about what the package is. And then we add, we changed some environment variables. For example, the Cray environment variables get set. We set some root paths and some directories so that compiler knows, okay, where is this package at? We set things in the path so that, okay, users can run these HDF5 programs that are in there. We set package config path and library paths so that when you compile, the libraries are in your path so that your compiler will pick them up. So now we're going to look at some compilation examples. So what you may have done on other machines or on even your personal machine is just GCC hello world or MPICC hello world. And while those will still continue to work on your personal machines, we don't do those on Perlmutter because Perlmutter is a Cray programming environment. And what that means is that the Cray programming environment has a set of compiler wrappers that take all of the different options and all of that stuff that you saw in the module files there, and it hides that information from you so you don't need to necessarily know about that in a wrapper command that wraps these compilers, okay? And so whenever you load your programming environment module, you will have several of these wrappers available. And these are what you should use when you're compiling your code. And that way you don't have to worry about adding the different libraries from the modules you load or anything like that. So if you take this example CPU code with MPI, you just see that you use capital CC, which is the wrapper, hello MPI, and then output it to that same name as a binary. You don't use -l MPI because the wrapper picks that up for you. You don't say where the library exists for MPI or anything else because, again, the wrapper picks that up for you. This is the same thing where you're doing OpenMP and MPI. In this case, you do specify a very specific OpenMP wrapper, and that's because OpenMP can be optional for a lot of different things. But again, you're still using, instead of you're using OpenMPI option, excuse me. But again, you're using the lowercase cc for a C code for the wrapper for this hello hybrid example. And when you're using GPU code, again, we're just going to use the wrapper, but you don't have to do any of the other things that you might have to do for CUDA or NVCC or some of that other stuff. All of this stuff is loaded by default, so you just need to make sure you have the correct programming environment and the GPU module loaded, and then you just compile your code. And then when you run it, you want to make sure that not only are you specifying the ranks that you're using, but also the number of GPUs that you're using either in total or per node. So we use a CUDA-aware MPI, and that means it's just something that allows memory transfer to happen better and faster if you're using MPI with GPUs. And again, that's enabled by this GPU module that we have and this environment variable that we set in it called mpitch GPU and support enabled. Now, if you were just using CPU, or if you swapped out this GPU module, you wouldn't have to worry about that. It would just turn all that stuff off. So here are some good compiler settings to know based on just general purpose compilation, right? And so the default optimization level, that's -O, for example, for optimization, and then it's O0, O0, O1 across the first line. If you want aggressive optimization, but may cause some problems with code if it uses certain kinds of math, you can use -O fast for the GNU compiler or Cray compiler, and NVIDIA has its own different type of fast options. Similarly for OpenMP, which again is not enabled by default, You have different OpenMP flags that you have for your compilers that you'll pass to your wrapper. Similarly with OpenACC and debugging and verbose about output. For more information on different options that you can set for the different type of compilers, you can do a man on the different compilers themselves. You can do a man on the wrappers, like man CC. You can do a man GCC, and that will give you different man pages for all those things. Otherwise, you can take a look at some of our documentation on docs.nurse.gov. So I'm going to talk about configuring compilers and libraries now. So again, we have these compiler wrappers that we're talking about, and they contain all of the flags that enable, specific functionality as based on your environment, your modules loaded, and what you're trying to do, right? And so, for example, if you add this craype verbose flag when you're doing a compilation, it will output all of the raw compilation command that's being used to build your application. And so you can see here that it's setting the Milan target, it's setting the NVIDIA target, it's linking in the MPitch version, it's linking in the libsci version, it's linking in a bunch of CUDA stuff. And again, these are all based on the modules that you already have loaded. So this is just for simple, you want to see what's happening under the covers. You want to know maybe if something is being loaded or not from a module, or you need to debug something. This is an option to kind of go in and look at. And again, same thing here. This is just a more complete option of what everything is there. And again, they work with these programming environment modules. So whenever you switch out to a different module, you're going to get a different compiler with different options underneath and different types of where everything is at. So again, if you have your programming environment on the far left, which is the module you will load and unload, depending upon which compiler you want to use, our default is the GNU compiler, and that's good for just about everything. Unless you need a very specific compiler, you should just stick with GNU. But we do offer compilers both from all of NVIDIA, Intel, and Cray. We also have LLVM compilers, even though the Cray compiler itself is also based on LLVM. We also have the new Flang that is part of our LLVM build. And these are just, okay, here is the wrapper on the left, and then what the actual compilation command would be if you use it on your home system. So you have capital CC, lowercase cc, and Fortran are all your wrappers. And for the MPI library on the right, all of them use a default Cray MPitch because it is optimized not only for our system and for your programming environment, but also for our network. So depending on the modules you load, the compiler wrapper links, you're going to get all of those things automatically added. Your MPI, your LPAC, your BLAS, your ScalaPack, all of that is a part of either Cray libsci or other Cray specific modules. If you want to know more about Cray libsci, you have an intro to libsci man page. Again, we have more docs on docs.nurse.gov. So for build systems, the main ones that you need to really look into are going to be CMake and AutoTools. In this case, AutoTools is usually used to generate make files. And so if you just have make files, we kind of put that under AutoTools. But for the wrappers, again, you want to make sure that when you're doing your compilation in either CMake, AutoTools, configure, make, whatever, switch out the compilers to use the compiler wrappers. Otherwise, you're going to have issues based upon whatever you're trying to compile. And again, there's more info here on how to do these types of things, both on docs.nurse.gov or in the man pages, or in the man pages on docs for the build tool that you're using. So if you're doing compilation from source with AutoComp, for example, for the GSL library, which is the GNU Scientific Library, You do a /configure, and then similarly, where in the previous slide, we put in all of the different CCs for the different wrappers in for the compiler. You run make, and you can pass in, like, for example, -J8, which means to run 8 different make jobs in parallel, and that'll make things slightly faster. And then you make an install based on whatever you put your default installation location. So if you're using something like CMake, there's a libxc build that you could use as an example. You can configure with either CMake or ccmake, or you can set these environment variables for your CMake C compiler, for example, based on the slide a couple back. And if you want to do for a build for CMake, you go ahead and just do CMake -- build with the J8. And again, that gets you 8 different make jobs to make sure that you're building your code in parallel, speeding things up. And then also you get your CMake install. So basically, in short, your best practices are use module spider if you want to search across all modules. Otherwise, use module avail if you just want to see what's available to you right now. Use the compiler wrappers, CC, and Fortran with the programming environment modules. If you want to switch to a different compiler, switch from programming environment GNU to programming environment like NVIDIA or Cray or whatever. If you have error messages, check the MIME files that are available, check the documentation. By all means, check Google, check your local LLMs, and also you can open issues with us. If you have more questions or you need help, again, help.nurse.gov is where to go. We also have a Slack channel that a lot of users will use to ask questions in first. Sometimes we're able to monitor that, sometimes we're not, but that's kind of it for the options for help. So if you have any questions, please feel free to share them in the slides or in the Q&A doc, and I'll make sure to take a look at those afterwards.
Any on the spot questions for Justin? Like you are good to go, and we want to give Justin a big thanks because he's taking a little moment out of his vacation to present to us. So much appreciated, Justin. And if nothing else, we will allow for you to get back to vacation with the family.